All right, our first item to look at are limits, and we're going to introduce the very basics to you in this particular video, and the focus will be on finding those limits through a graphical approach. Three things that we want you to know when you're all done. We want you to understand what limit notation means and how it's written correctly. We'd like to learn about how to find one-sided limits graphically, and also we would like to learn the basic limit definition and determining if it has a limit or not. The first thing we find out is how important the word approaching is. You can see it here and you see it here. And it is at the heart of the definition of what a limit is. So it says, as x approaches a particular value, what is y approaching? Again, focus on the word approaching. That is the key part of this. It's not where actually we are physically at as an x value. It is what we are approaching. So when we look at the way that the notation works, we see that very same thing here. This says the limit of f of x, or of the function, as x approaches c. Now c is just a value. It could be 2, it could be -5, it could be 13, it could be anything. But as x approaches that value, what does y approach? And again, what y approaches is the L, our limit. L is the value that y gets closer and closer and closer to. That's the limiting idea. It's not necessarily what the number physically is, and you'll see why I keep emphasizing that. So how it's said, if you were to say it in a sentence, is just the limit of f of x as x approaches c is L. And L represents the limit of that function as x approaches c. So let's look at some examples. So let's do a little quick review of just functions. This is f of 0. So ultimately what that means is we go to x equaling 0, and we want to know the function's value at 0, which is 2. So in goes our 2. Next, we would like to know the function's value at 1. So here we are at 1. Now, our piecewise function tells us, wait, we're not actually here at -1. Where are we? We're all the way here at 3. So the value of the function at 1 is 3. Where's the function at -2? Now this, of course, is a piecewise review from previous years. At -2, we are not here because it's the open dot, so we are here at 3. So that just simply, again, is a bit of review. Now, let's go to what we've learned about functions now. And limits. So this is the limit of the function as x approaches 0. So let's look at that. When x is 0, how are we approaching that from the two sides? So from this side, as we approach 0, we're coming to 2. From this side, as we're approaching 0, we're coming to 2 as well. So this value becomes just simply a 2 there. And again, why is that? Because as we are closing in on 0 from the two sides, as we're closing in on that, our y value is heading towards that 2. The next one is the limit of the function as x approaches 1. So we're approaching 1 from this side, and we're approaching 1 from that side. And what y value are we approaching as we go? So from this side, we're on our way down to -1, and on this side, so are we. Here is the perfect example why earlier I was warning you. Some will say, well, wait, the answer is all the way up here at 3. No, we are approaching -1 from both sides, and so the limit is a -1 value in that position. As we look at this last one, we are looking at the limit of the function as x approaches -2. So we're looking at it as x is approached -2 from both sides. Now, on this side, you'll notice that we are approaching the y value of 1. On this side, coming to -2, we're approaching the y value of 3. Those are different from the left and from the right. And so what we write for that into that spot is does not exist. DNE represents the limit does not exist. Again, this is a beautiful example of the earlier discussion about what it approaches and not what it is at. We can talk about one-sided limits. So let me show you what that means. In this notation up here, this talks about as x approaches c from the negative side. So that is a one-sided limit. So if you're looking at this one, it says what's the limit of the function as x approaches -2 from the negative side of things. So that would actually be approaching it from this way. And as we approach it this way, our value would be the 1. Right? Because what are we approaching when we're coming here? We're approaching a y value of 1. If you go to the other way, this would mean the limit of the function as x approaches c from the positive side. So if we were doing that problem and approaching -2 from the positive side, we would be coming and we would be heading our way towards a 3 value. These two numbers are different, aren't they? They approach from the right and from the left in two different values, and so we know that this means that the limit does not exist. So that comes to the general limit definition. Let's look at that. All right, this is really the focus of this whole lesson or video, is the general definition of a limit, the general limit. So this says the limit of the function as x approaches c is L. That can only be true if two things, if and only if the following two things are true. If you approach c from the negative side and you get L, and if you approach c from the positive side and you also get L. If you get the same value from both sides, then the general limit exists. But on the other hand, like the example we just did, if you get different values, then the limit as it approaches c does not exist. It must be true to both sides. Let's finish with a couple examples. So let's have you try these 4. All right, let's go over them now. This means the limit of g of x, which is our graph over here, as x approaches -2 from the negative side. So that means we're approaching -2 from this side, and if we follow that along, we see the value that it's approaching would be a 1. So our answer for this would be a 1. In the next case, we're going to look at the limit of g of x as x approaches -2 from the positive side. So from the left side, from the right side coming this way. And so as we track that down, as we come along here, we recognize as we're approaching from the right side, there we are, we hit our value of -1. Now the next question asks, is there a general limit there, not a side limit, but the general limit? And our answer, I think you know the answer. We got two different values here and here. So our answer is it does not exist. Now just as, again, a review and an emphasis of a point, if I was to ask you what g of -2 is, I think you would see that the solid dot puts us here at -1. A limit does not exist, but there is a value at that given time. One last example here. We're looking for the limit of g of x as x approaches 0 from the positive side. So as we approach the 0 value from the positive side. So when we do that, let's track that down from the positive side. As we head to x equaling 0, we are approaching -3, are we not? Now, the next one, we are going to approach 0 from the negative side. So if we were to do that, if we were approaching 0 from the negative side, we would be coming this way, and we also approach the value of -3. The next question is not a single side limit, but the general limit for that function as x approaches 0. And because both those values are the same, then we do have a function, and our value would be a negative 3 would be the value at that given moment in time. And that's because the right and the left both produce the same value, so a limit exists. Here is a great example, though. Even though the limit exists at negative 3, the actual value at g of 0, if you look over at the graph, at g of 0 is actually this solid point here at negative 1. These were purposely picked to show you really, again, not what it actually is at, but what it physically approaches from the right and from the left. Big ideas is a limit is not what is physically at with that x value, it's what's happening very close to it as we get closer and closer to it. I love the word approaching. And then finally, you learned what it meant to be the general limit, and for it to exist, two things had to be true. The right and the left limits must physically be the same value. Otherwise, then there is not, it does not exist. It must happen from both sides to exist.